Here we are being asked to find both a recursive formula and a general formula. Looking at the sequence, we notice that we are multiplying by 3 to go from term to term to term. So if we are looking for a recursive sequence, you need two pieces of information. A1, which is 4, and then a formula for the nth term. I'm going to write a sub n is equal to 3 times a sub n minus 1. Now, if we didn't want to write it this way and we wanted to say that the n plus first term is 3 times the nth term, that would be acceptable also. As for a general formula, well, we all know the formula a sub n equals a1r to the n minus first power. Let's just substitute in what we know. A sub n is 4 times a ratio of 3 to the n minus first power, and when you start substituting values in for n, you will notice that you actually generate that series there. Okay, let's start with a recursive sequence in this next problem. We need a first term, which is 38, and then a way to write the nth term. Now, looking at this pattern, to go from term to term to term, we are adding 7. So the nth term will be the term before it, a sub n minus 1, plus 7. If we're looking for a general formula, we would probably start with the nth term formula, a sub n equals a1 plus n minus 1d, and substitute in what we do know. The nth term is a1, which is 38, plus n minus 1 times 7. This gives us 38 plus 7n minus 7, and so the nth term can be written as 7n plus 31 after you combine like terms. Find a1 for this arithmetic sequence with a 43rd term of 218 and a 51st term of 507. So we've got a1 way out in the front here and a bunch of blanks until we get to 218, which is the 43rd term, a bunch more blanks until we get to 507, which is the 51st term. Find a1. Well, my recommendation here is that we relabel our subscripts. Cut off the first 42 terms, relabel this first term as, or the 43rd term as the first term, noticing that we are subtracting 42 from the subscripts. Come over here to the right, subtract 42, and call this a sub 9. That would be our 9th term. Now let's use our an formula equals a1 plus n minus 1d to find out how far apart these terms are. Turns out that 507 would equal 218 plus n minus 1 times d. Subtracting the 218 off of each side gives us 289 on the left is equal to 8d. And then dividing by 8, it doesn't go in evenly, d will turn out to be 36.125. Now that gives us our value of d. Now, I want to find a sub 1, and I don't want to subtract 42 from the subscript that we have up here and have a negative subscript. So I'm going to return to my original subscripts. Let me write that down so you've got that in your notes. And I'm going to use the nth term formula again. A sub n equals a sub 1 plus n minus 1d. And as far as my nth term goes, I can either say here's my first and here's my nth, or there's my nth. I'd rather go with the smaller numbers. A sub 43 equals 218. So 218 is what we get when we start with a1, still unknown. 218 was our 43rd term, so I really have 43 minus 1 times that d value of 36.125. Okay, 218 is A1 plus, when you multiply 42 times this 36.125, you get 1,517 and a quarter. Subtracting that decimal off of each side will tell us that A sub 1 is then equal to negative 1,299.25. Find the sum of the first 100 even numbers. That is 2 plus 4 plus 6 plus ... Not up to 100, but up to 200. 200 is the 100th even number. This is an arithmetic sequence, not sequence, but series, because we have addition signs. The value of D is 2 because even numbers are 2 apart. So our sum will be n over 2 times a sub 1 plus a sub n. We're trying to find this sum. It will be 100, that is n, there are 100 numbers there, divided by 2, times first term 2 plus nth term 200. Multiplying this out, we get 50 times 202, which is 10,100.